Hello. We're pleased to be back after a summer break with the next in our series of MRI safety webinars, this time specifically for all of those who have a role in the design of MR facilities. My name is Colin Robertson. I'm Senior VP with Metrasense, and we're all very excited to be hosting this webinar today. For those of you less familiar with Metrasense, we're the leading provider of advanced magnetic detection technologies. Our FerroGuard ferromagnetic detection systems are protecting patients and staff now in 36 countries around the world. Before I hand you over to Tobias Gilk, our speaker today, I have a few housekeeping items to quickly cover to make sure we all get the most out of our time together. Firstly, today's session will be available on demand after this live version. Just follow the same link as you used just now, which will also be in the email we'll send you after the live session. Of course, please feel free to share this with any of your colleagues who are unable to attend today. I'd now like to quickly take you through the various parts of the screen you're looking at. Starting on the left side is the Q&A window. So if you have questions to ask about the webinar, please enter them here. If we don't get to your question today, we'll be sure to follow up afterwards. The window in the center of the screen is where you'll see the slides throughout the webinar. If you'd like to change the sizes of any of the windows, just use the controls at the top right corner of each window. To hide or redisplay any of the individual windows, just use the buttons at the bottom of your screen. At top right, we're also pleased to provide links to some valuable resources regarding safety in MR facility design. Please do take time after the webinar also to visit Metrasense MRI Safety Resources page. You'll find a link there. There you'll find all our previous webinars to view on demand and lots of other valuable MRI safety information. The final window, lower right, gives you a brief biography of Toby Gilk, our speaker today. He's going to introduce himself in just a few seconds, but I should say that Metrasense is very proud to be able to bring him to such a large audience today. And finally, at the end of today's session, you'll see a quick survey that we'd really appreciate you to complete. It will take you just a couple of minutes and will help us set the agenda for Metrasense future webinars. Many thanks. So, you'll be pleased to hear that's enough of me. Let me pass you on to Toby Gilk.
Thank you very much, Colin, and I'm so glad that you could join us today, all of you who are calling in. Today's webinar is going to be on MRI safety, customer satisfaction, and by customer here we mean the hospitals or imaging centers, the imaging provider, and the architect or planner's role in each of these. And as Colin mentioned, my name is Tobias Gilk. I am a certified MR safety officer and MR safety expert, certified by the American Board of Magnetic Resonance Safety. I am trained as an architect with radiology planning. I'm a member of the FGI's Healthcare Guidelines Revision Committee, special consultant to the ACR's MRI Safety Committee, and founder of my own Gilk Radiology Consultants, which is ongoing consultants to Metrasense, who is making this webinar possible. So over the next 40 minutes or so, these are the elements that we're going to touch on. The first of which is, with respect to MRI facility planning and design, need for increased level of involvement on the part of the planners, the designers, a better understanding of the functions of MRI facilities clinically and operationally such that the designs can better meet those needs. Identifying key elements with respect to MRI safety that designers really need to be aware of. We're going to touch on some resources that are available to you to help planners, designers, engineers, equipment planners be able to expand your knowledge and expertise in this area. And then we're also going to talk a bit about customer satisfaction and a different philosophical approach, if you will, to looking at these projects that I think will improve the project performance and ultimately, therefore, will improve the satisfaction of the people who live in and work within these facilities on a day-to-day basis. For the designer, that means your customers. So the first item on that overall agenda list is the designer's involvement, increasing the level of project involvement on the part of planners, designers. And there are really sort of 4 bits that we're going to touch on in this. We're going to talk about the planner or designer's role in minimizing risks and accidents. We're going to talk about the role of the OEM, the original equipment manufacturer, the Siemens, the GE, the Canon, the Philips, the Toshiba, their role in taking care of these safety and planning related issues, where that line is in the sand, where that transitions from the manufacturer's responsibility to the planner and designer's responsibility, and where it gets handed off ultimately to the operator. We're going to talk a little bit about accrediting organizations and their role in assuring minimum standards for MRI facilities, safety and operation, and then we're going to talk about the hospitals themselves, the radiologists, the radiographers, the technologists, the administrators, and what we want from them as planners and designers that sometimes they provide us automatically, and sometimes it requires a bit of asking to get to that same level of information. So the first of the areas that we're going to cover is the degree to which the design of a facility potentiates risk or the risk of a harm. Said another way, the degree to which the design of an MRI facility potentiates safe MRI practices. The physical environment helps to shape behavior, and then the question becomes, is the behavior that physical environment, the design of the suite, is the behavior that reinforces or supports the best practice behavior? And what's the designer's role in helping support safety best practices? So that's what we're going to take a look at. Probably the best known, most widely recognized risk in MRI is the likelihood that the magnet is going to draw something to it. In this webinar, it's difficult to show videos, so I've sort of created a little stop motion collection of images, individual frames from a video that show a pipe wrench. If you start in the upper left-hand corner and you go top row left to right, and then you jump down to the bottom row and again left to right, you see these frames in sequence. What you don't see is to the left of each one of the frames is an MRI scanner, and that gray plane behind the brick is a piece of gray painted plywood, and there's a little shelf, and the brick is standing on the shelf. And then if we look at the upper left-hand frame, there's an orange blur that's sort of coming in from the right-hand side. That orange blur, as you see in some of the later frames, is a pipe wrench. So what we are seeing in this series of images is a pipe wrench that is magnetically attracted to the MRI on the left-hand side, and it comes flying in from the right-hand side and strikes a couple of bricks that are set on a little shelf on this piece of plywood. This is illustrating the degree of force that MRI scanners are capable of creating in magnetic or magnetizable materials, in this case a pipe wrench. And if you follow the frames 1, 2, 3, 4, 5, 6, what you see is a wrench flying at the MRI under no power other than the magnetic attraction from the MRI scanner. That wrench strikes the bricks and pulverizes the one that it hits. And in the last frame, you can see bits and fragments of dust, shrapnel, if you will, of the pipe wrench striking the brick. This is one of the real risks associated with MRI. So how does that pertain to planners or designers? There's really not a lot we can do in terms of planning a facility that will keep somebody from walking in the room with a pipe wrench, is there? So let's take this one example. This is an adverse event report that's actually pulled from the US FDA. They call it their MedWatch program. The database that you can access this from in terms of public online searching is called the MAUDE database. There's lots of information that's extraneous to our purposes, but if you look at the event description, that little 2-line paragraph down at the bottom, and this is a patient who got injured because the patient was entering the MRI scanner room with a walker. Presumably, the patient needed it to help keep balance and keep them from falling. Well, the walker had ferromagnetic components. It's not a pipe wrench, but the magnetic attraction effect follows sort of a similar path, that the magnet, the MRI scanner, essentially pulled the walker out from under this patient, and the patient fell and was injured as a result of it. This is just one illustration, but it prompts the question, what could the designer do to help minimize this as a risk? A couple of the potential responses are, as a part of the design of the facility, we could anticipate additional equipment, whether it's wheelchairs or transport beds or gurneys, whether it's walkers or crutches or something that we know to be safe in the MR environment. It's a limited number of devices, object support material that would go towards promoting safe operation in the environment. But if we don't actually have a place to put those things, then it makes it very difficult to store them and keep them at hand. So simple things like a quarantine closet to lock up unsafe objects that patients bring with them to the MRI facility, and storage space to allow for things that are safe to use in the MR environment. So using the walker example, how do we extrapolate from that? How do we look bigger at what the designer's role is, or could be, should be? I believe that the designer should have an understanding of the operational model. Who are the patients? Where are they coming from? Where are they going to? What are we doing to them at the various stages in the process? What do we need to make sure of from a safety standpoint that is happening, or things that we prevent from happening, to make sure that we protect the safety of the patient and the caregivers? Do we understand what equipment gets brought to the MRI suite, and whether that's safe to continue all the way into the room with the MRI scanner, or whether we need to look at making swaps and substitutions like with our walker? Do the designers help identify what appropriate equipment to the MRI environment is? An architect or engineer may, not like the idea of helping the facility with things like MR conditional wheelchairs or fire extinguishers or that kind of thing. But quite frankly, it is all part and parcel to the function of these physical environments that I believe the designer should take a more active role in. Can we identify things that might live inside the MRI suite that we know are unsafe? Are those things that we can exclude or remove from the controlled access portions of the suite? Or can we do something to make them more conspicuous, to make it more obvious that this object or device really shouldn't continue towards the MRI room? Spaces with quarantines for unsafe material or equipment, and storage for safe equipment. These are all things that I believe designers can take a more proactive role in helping to make sure these facilities are appropriately planned, so that the function and the design of the space work hand in hand instead of fighting one another. And here I'm going to use a couple of photos of MRI accidents to help kind of drive home some of these points. So the picture we're looking at right now shows a hospital bed stuck on the face of a magnet, an MRI scanner. This happened at a very prominent academic medical center. So we can't pretend that these accidents only happen at backwater locations. The things that make these accidents happen are pretty ubiquitous throughout healthcare. But what's the designer's role in helping to prevent this accident? So if we identify appropriate transport equipment, we make sure that there is storage space for transport equipment. Maybe this hospital bed was brought in because we have a bariatric patient and we don't necessarily have a patient somewhere else. And so we can't move them to the MR safe, MR conditional transports. All of these elements are part of the planning and design of the MRI facility. So while the ultimate decision to roll this patient bed into the MRI scanner room was made by a staff person, that person may have made that decision based on the unavailability of an MR conditional device or storage that wasn't in the functional path of taking care of that patient, or the absence of a patient lift system for this particular patient. There are a number of elements related to the physical environment that shape the decision-making of the clinicians at the point of care. And we, as designers, need to understand our role in that part of the process. So this is one of them, and this is another. This image, it's kind of grainy, it's hard to see, but what you're seeing here is a crib, infant being brought from a pediatric or nursery unit being brought for MR imaging. And if your infant is sick to the point where they're in the hospital, they need advanced medical imaging, probably the last thing you want to do is involve them in a car crash kind of scenario, like bringing a ferromagnetic transport into the scanner room. This also, as you notice, the actual table that's mounted on the floor here is kind of listing to the right. Not only do we have the concerns about the patient, the infant in this case, but also damage to the equipment. Similar set of concerns and considerations. This one we're going to ask about the patient mix. And while we may think generally about MRI patients as adults, what does it mean when it's a pediatric population, or a geriatric, or a bariatric population? Or what does it mean when we have a disabled person? So here we're seeing sort of a more exaggerated version of the damage from that previous slide, the crib slide. But here what we're seeing is a motorized wheelchair or an electric mobility scooter. Inside the bore, the tunnel of the MRI, you're seeing the remnants of that device that got sucked in there and completely knocking the floor-mounted MRI patient table off to the side. So here we have three fairly dramatic illustrations of the ways in which the physical facility can precipitate a set of decision-making that leads to projectile-related accidents. Projectile accidents are not the only ones, but they're ones with really profound visuals, and I hope that these pictures help to reinforce this point for you. Which brings me to one of the questions, or actually, quite honestly, one of the forms of pushback that I get most frequently when I suggest increasing the role, the involvement, the responsibility of planners and designers of MRI facilities. And that pushback is, but wait a second, isn't that taken care of by Siemens, by Philips, by GE, by the equipment manufacturer? I mean, we get these detailed drawings about the installation of their equipment. They got warnings in their manuals. Can't we count on those safety-related elements being resolved by the equipment manufacturer or equipment provider? And the short answer to that question is no. Unfortunately, we can't. In fact, the manufacturers disavow major pieces of the responsibility. Now, the equipment manufacturers do assume responsibility for their equipment, their device, their product, anything that has their logo, their label on it. But once you get beyond the things that have their logo on them, now you're really outside of the range of things that the manufacturer assumes responsibility for. For example, there are all kinds of disclaimers in the contract language and the operator's manual essentially saying that the equipment manufacturer is not responsible for any decisions, point of care related decisions that might produce an accident or harm. If their device malfunctions, yes, that's on them. But quite frankly, the MRI accidents that occur, the proportion of them that are directly attributable to some sort of malfunction of the MRI equipment is almost immeasurably small. The results that produce injuries, accidents, harm, damage to the equipment, those events are almost always point of care decision-making, operational related issues. So the OEMs, the manufacturers of the equipment, explicitly disavow that responsibility. So what we're really talking about is we're talking about the clinical and the technical staff who are there, the boots on the ground, and their need for facilities that really help them, help to direct decision-making, influence decision-making in a way that promotes the best practices, the safest operation. And that's where the imaging designers, planners, that's where their role becomes increasingly important. So our first audience feedback participation question relates to the role that accreditation plays in terms of assuring facility safety, physical environment safety within MRI. So we'll ask the question, and then please click the radio button that most closely aligns with how you feel about this. So the question is, do the accreditation programs, such as the Joint Commission or the ACR, do those accreditation programs assure some effective level of MRI facility safety? First answer is yes, that's why these programs exist, for things like guaranteeing physical environment safety. No, while they touch on safety from the physical environment standpoint, they don't really require it. Or the third one is, I don't know. So please select the one that most closely aligns with your thoughts and feelings on this, and then we will take a look at our answers here shortly. Okay, time's up, and we are moving on. The next most frequent source of pushback that I get to the idea of the designer taking a more direct role in patient safety is, okay, well, if not the manufacturer, then the accrediting organizations, right? Every accrediting organization has in their logo something about assuring quality and safety, right? So if they're Joint Commission accredited or ACR accredited or DNV or IAC or any of the other alphabet soup accrediting organizations, if they have that, doesn't that demonstrate safety? And we can count on it demonstrating safety in different parts of the healthcare enterprise, but unfortunately not so much in MRI. So do we depend on accrediting organizations to assure safety in the physical environment and the execution of clinical care in that physical environment? No. Joint Commission does have some minimum zoning requirements and some minimum annual safety training requirements. But each of those two requirements are really rather ambiguous and anemic, and the Joint Commission has really not made a point of emphasizing these elements in surveys. So while they might appear on paper in whatever condition you wish to evaluate them in terms of their seriousness on paper, the actual implementation of this is pretty weak at this point. So it doesn't really matter what it says on paper if it doesn't get implemented the boots on the ground in the clinical provider location. The ACR requirements are virtually all related to have a policy that states fill in the blank, or have a policy that addresses fill in the blank. In terms of physical environment requirements from the ACR, no, not really. And in terms of thou shalt do it this way, again, no, not really. They do require, as I say, policy and documentation. You just don't, those policies don't have to follow best practices. And even if the policy written follows the best practice, there's nothing that the Joint Commission, or excuse me, there's nothing that the ACR does that says, I want to make sure that you implement the policies as you have them written. As long as they're words on paper in a binder somewhere, that meets, apparently, the ACR's minimum requirements for their elements. Now, what I've just told you about the roles of the manufacturers, the equipment manufacturers, and the roles of the accrediting bodies not being really active at all in physical environment safety stuff, this strikes a lot of people as weird, as counterintuitive, because we all know there are massive amounts of regulation related to radiology. Well, here's the thing. Almost all of those regulations on safety in radiology pertain to ionizing radiation exposure, the radiation that makes you glow in the dark. Okay, it doesn't really make you glow in the dark, but you get the idea. The does chromosomal damage type of radiation, of which MRI is outside that. MRI is non-ionizing radiation. And so it's almost as if, well, because the rules for ionizing radiation don't, because MRI is non-ionizing, we can't apply those rules. It's almost like somebody said, oh, well, in that case, MRI doesn't need any rules. And that's really kind of where we find ourselves today, where the rules that the accreditation organizations or the manufacturers or the state licensure authorities or the FDA with respect to point-of-care patient safety or staff employee safety, they don't really exist. So that puts a greater burden on everybody who helps to shape the physical environment and the process that occurs in the physical environment, which again circles me back around to my original premise that we need to increase the level of involvement of the designers. And here are the results of our first poll question, feedback question, about accreditation programs assuring MRI physical environment safety. Oh, all right. We won't delve into this right now. If there are questions or concerns about this, we'll touch on this on the Q&A side of things. Okay. And we move on. So if I've convinced you that the designer needs to take a greater role in this, there's still an argument to be made that, okay, I will do more. I just need the users to tell me what it is that they want or what it is they need. And if they tell me they want this, 2 feet wider, 10 feet taller, left-handed instead of right-handed, I will do that. But I'm going to depend on them to bring this information to my attention. There are only a couple of problems with that premise. One, if we're all working from the same resource materials, right? What does the Joint Commission and the ACR, what do they require? What information do I get from the OEM? What's in the existing building codes or design standards for MRI facilities? If we're all using the same resources, it may be that the end users, the hospital employees, they may not have a clear indication as to what the best practice or best practice as it would apply to them is. If you, as the designer, don't have this information, I would not be 100% confident that has this information either. And it may be that the two of you need to, through a question and answer exploratory kind of process, need to identify how do you want to work? What is the process you'd like to employ? What does that mean in terms of physical environment? The other thing that I have seen working in a number of hospitals, a number of healthcare enterprises, the people who have that information, if it does exist on the client side, may not be the ones who have a voice at the table. The picture of our last staff meeting, but I've worked with facilities where my imagination leads me to believe that this is what staff meetings might look like. And there may be people involved in the project whose names appear on the meeting minutes and that kind of thing, who don't feel as though they actually have the opportunity to provide their input, or that they have given input but it got buried somewhere and never really communicated and passed along. The designer's role, in my opinion, is partly to be marriage counselor, partly to work with client groups that may be prone to dysfunction or poor communication, and help to make sure that questions or concerns about the people at the front lines of the operation, that those questions are up and that the designer understands what they are. Because after the facility is constructed and somebody goes, I really wish we would have done it this other way, that's not the time that you want to hear that concern or that suggestion. You want to have that brought up at the beginning and put that into the mix, considering all of your design options and strategic approaches. Next, we're going to take a look at 3 areas of physical environment design for the MRI suite and the designer's role in that. And the 3 things we're going to zero in on are the 4 zones, the ACR 4-zone model, quench pipes, and the use of ferromagnetic detection systems in MRI. So let's take a look at these. So the first of these, the 4-zone principle, and this is an element that's been published since 2002, the original ACR white paper on MR safety. It's been incorporated in the FGI guidelines for design and construction of healthcare hospital facilities since 2010. The fundamental idea of this is, as we move from public spaces out in the world, the Starbucks on the corner, as we move from these spaces closer and closer to the MRI scanner, we're going to undergo increasing levels of screening, supervision, and access restriction. What does that look like conceptually? In my mind, it looks like one of those nesting Russian dolls. The MRI is at the very center. It's the nougat in the middle, if you will. But then we have these shells or layers or zones that surround the MRI. And in order to pass from from ring to ring, from shell to shell, to zone, we need to undergo increasing levels of supervision, screening, and increasing access controls that prevent us from going to the next level until we've demonstrated whatever it is we need to demonstrate for effective safety. So this is it kind of conceptually, the nesting Russian dolls. What does it look like organizationally? So on the screen right now, we're seeing an org chart, if you will, a process diagram of many of the elements of many MRI facilities. This doesn't necessarily apply. All bits in this diagram don't necessarily apply to all MRI providers, but this gives you sort of a general indication. And if you're looking at this on your phone or a small screen and you can't read this, check out the resources links. This is from the ACR guidance document on safe MR practices. And this illustration, you'll be able to see it full size, and it will help you. But essentially what we're doing is we're associating Zone 4, the room with the giant superconducting electromagnet, as we go from public spaces towards that MRI. Depending on the relative levels of risk, we increase, as I say, screening, supervision, and we ratchet up the access controls, access restrictions to be able to move further in this pathway. That's the general principle of the ACR4 zone. So the second element in my list of 3 for designers and MRI safety is the quench pipe. MRI scanners, most, but not all, MRI scanners today have thousands of liters, hundreds if not thousands of liters of liquid helium inside the scanner device itself. You may see a plastic shell, but inside the plastic shell, under several layers, is effectively a donut-shaped thermos bottle. And that donut-shaped thermos bottle has hundreds or thousands of liters of liquid helium, which Fahrenheit is about 450 degrees below zero. When that boils, when that turns from a liquid state to a gaseous state, it has to escape. And that's the role of a quench pipe, essentially a chimney. It discharges that super cold gaseous helium. And anybody who's exposed to that gas is at risk of being turned into a popsicle. The gas expands as it warms, which means in-swinging doors, if there isn't a pressure relief mechanism, can lead to entrapment inside rooms. The volume of the gas is such that it will begin to displace the oxygen in the room, so leading to asphyxiation risks. And of course, it's 450 degrees below zero. So there are all kinds of health risks that come with exposure to such incredible cold as well. And like a chimney, the quench pipe has to exit the building somehow. This is an example of what I personally feel is a poor design, where it goes up through the roof, in this case, turns 90 degrees and discharges horizontally. Wind-driven rain can actually force its way into the end of the pipe if the wind is blowing in the right direction. You really want one that prevents even horizontally driven rain from entering the end of the quench pipe. But this is just an example of what one may look like on the roof of a hospital building or an imaging center. Sometimes they come out the sidewall, but this is just a discharge end of the quench pipe for your edification. The third element of the MRI facility designer's role in improving safety is ferromagnetic detection. And the idea behind this is we're using not conventional airport-style metal detectors that alarm on all metals, but we're using a specialty type of magnetometer-based detector that only alarms on materials that can be attracted to the magnet, that can become projectiles. We want to identify these objects, these materials, before they get brought into the MRI scanner room. And I'll show you an example. Actually, I will show you 2 examples in this slide right here. So on the left-hand side of the photo, you can see an MRI room door. You can see the familiar signage on it. Flanking the door on either side, left and right, are doorway entry protection style ferromagnetic detection systems. On the right-hand side of the image, you see the single white pole mounted on the wall. That's a screener system. This image I chose because it has both systems in a single picture, but this really represents the best practice combination. That you use the screener, the object on the right, typically located in a zone 2 area, adjacent to patient changing areas and patient lockers, where you double check and make sure that when you ask them to change or empty their pockets or whatever, that they've actually complied with that in the location where it's easy to make any corrections. The second step in this, and actually the one that is most commonly deployed when a site deploys just one, is the version on the left, the doorway protection systems. Now, there are suggestions that you can put them on the outside of the magnet room or the inside of the magnet room. Actually, the ACR says that you provide ferromagnetic detection approaching zone 4. If it's inside zone 4, I don't know how that actually complies with the ACR guidance document. Plus, you really want the opportunity to visualize the alerts, the information from these detection systems before you're, at or going through the door. So both the ACR and me personally don't put them inside the magnet room, put them on the outside, more similar to what you see pictured here. And now for resources, and I'm going to provide you with 3 of them that I think are really valuable for the items that we've discussed today. The 2018 Facilities Guidelines Institute, the ACR guidance document, and I'm going to point you to a specific appendix within it. The whole document is great, but for designers, I'm going to focus your attention on an appendix, and the Metrosense Architects Pack for siting ferromagnetic detection systems. But before I get into the various resources and the basis of recommendations, I want to ask you what you use for resource for MRI safety when it comes to the physical environment, to the design, the construction of an MRI suite. Do you use one of the more contemporary FGI guidelines, the 2014 or 2018? By the way, use the 2018 if you have a choice. Do you use one of those? Do you use the ACR 4-zone model? Or do you use the ACR's facility safety design guidelines, the appendix in the ACR guidance document? Check any and all of the ones that you use for this. And I'll give you just a moment longer since I'm asking you to check all that apply. Okay, time's up, and we are moving on. The first of these 3 references is the guidelines document. This is the FGI, the Facilities Guidelines Institute publication. On the screen right now, we're looking at the 2018 version, and I strongly recommend for any imaging using the 2018 over the prior versions. Even if your state, for its licensing authority, uses an earlier version, I would strongly recommend that you use the 2018 edition just because it has better information and will help more effectively guide the designs around that. I also made reference to the ACR guidance document on safe MR practices. 2013 is the most current full edition. There's a 2019 document that identifies some updates that will be part of a new fully re-released version of the document. But from a designer standpoint, let's stick with the 2013, both because it's a full and complete document, but also because it has the appendix that I also mentioned. That is Appendix 2, which, if you're a designer, this title of this should be, smack you in the head, straightforward. MRI Facility Design Guidelines, MRI Facility Safety Design Guidelines. And it essentially walks you through functionally how these facilities are used. And it explains the zoning, it explains the individual elements of a number of clinical operational processes and how that should be shaped by the physical environment. If you are a designer, I strongly encourage you to kind of read through this section as a part of any MRI facility planning job. And the third reference that I'm going to point you to is available on the Metrosense website. And this is the Architects Pack. This is the planning guide for planning facilities and siting ferromagnetic detection equipment. When I say planning facilities, this is not simply a question of having wiring connections to the right spot or backers in the wall for mounting the wall-mounted bits. There are a couple of things that I would like you to be aware of in terms of designing, planning the facilities, and how those decisions can make these products work even better. And so here, let's take a floor plan of a prototypical MRI suite, right? System component room, equipment room on the left, the MRI scanner room in the middle, and the control room on the right. And here you see we have entry from the control room into the scanner room. But the ferromagnetic detection system at the doorway, let's zoom in on that doorway and get a closer look, shall we? And here we see the zoomed in view of the door from the control room on the right into the magnet room on the left. With positive pressure relief somewhere other than the door, we can swing the door whichever way we want. My recommendation is the door should swing into the magnet room. You'll notice that there's an additional thickening of the wall at the doorway. Now, MRI room walls are thick to begin with because of the way that they're built and the shielding required and grounding isolation. Notwithstanding the normal thickness of an MRI room wall, I'd like you to think about adding, say, 6 inches of thickness right around the MRI door opening. Remember, we want to mount the ferromagnetic detectors on the outside of the door, the control room side of the door, the right-hand side in this illustration. Not put them inside the room. We want to comply with the ACR and having the screening in the approach to Zone 4. But the thickening of the wall really does something wonderful for us. I have not yet come across an MRI room door that does not have ferromagnetic components. And then we're going to mount a ferromagnetic detector right next to or on the wall surrounding the door opening. There is the potential that the detector will detect motion of the ferromagnetic components of the door, which doesn't really help us all that much. We want to screen people and equipment coming and going. We don't want alerts and alarms from the door movement. Adding a little bit of thickness, as little as 6 inches, to push the ferromagnetic detector away from the door decreases the potential for the spurious alarms from the door motion. Just as little as 6 inches. If you can do more, great. But if all you can do is 6 inches, add 6 inches to the thickness of the wall at the MRI room door. You'll notice if you look at this plan detail that thickening isn't just immediately around the door. We actually, in this drawing, extend it 3 feet up on this plan to push the operator's console at least 3 feet or a meter away from the corner of the opening where we're going to put the ferromagnetic detector. Just like we don't want the detector alerting or alarming on the door, we also don't want it alerting or alarming on the motion of the chair that the tech sits in, or the fact that they're using a stapler to staple some documents together, or they're picking up the handset to the telephone. We don't want those spurious alarms. When we do these subtle modifications to the entry that I'm asking every designer make a standard part of your design protocol, when we make these little changes, what that means is we can dial the sensitivity of the ferromagnetic detector up higher, catching more stuff, and at the same time reduce the spurious alarms. So an extra 6 inches of wall thickness is really a win-win. We give up almost no square footage from a practical standpoint, and yet we improve the sensitivity and we reduce the spurious alarms for the ferromagnetic detection system. So again, please make this a standard part of your design approach for MRI room entries from this point going forward. And circling back to the responses to which of the design resources you use for MRI facility safety design construction. Okay. All right, I find this a little bit surprising. All right. Again, as with before, any questions or concerns, and we can speak more about it during the Q&A session. Thank you for your responses, by the way. And the very last thing that we're going to touch on in the outline for this webinar is the designer's role in customer satisfaction. Now, I am an architect, so I'm not maliciously maligning my own profession, but typically the architect's responsibility ends with ribbon cutting, right? Maybe we send the photographer in to get some pretty pictures after everything's up and running, but really we're done. We walk away. That, however, is the point at which our clients, the architect's clients, the operators of the facilities, the radiologists, the techs, the admins, the nursing, the aides, that's the point at which their role begins. So architects get to walk away from whatever operational problems there are. They don't have to deal with those, but the clients have to live with them. And that represents sort of a disconnect between designers' responsibilities and the function and the operation of the facility. I realize I'm asking for us to essentially break the mold, to go against what has been the historic model of us waving goodbye, the designers waving goodbye, and leaving the facility operators to their own ends to live with whatever decisions were made, without really sort of a functioning feedback loop to the designers. So if there's not a direct inquiry and feedback process during the design period, and there isn't one after, architects, engineers, and planners can wind up replicating the exact same mistakes over and over and over again and be none the wiser for it. So what are we as designers, what should we do to create a positive feedback loop to help us generate better design products for our clients that work better for them, facilitate their clinical care of their patients? I don't have sort of a silver bullet for you, but I do have a number of questions that I think designers, planners should be more actively asking of their MRI project clients and user groups. One of them is to think about operations. If you don't understand what a facility's operational model is, that's okay. Ask the question. Also be aware that if you ask the question, they may give you the operational model that they currently operate under, even if they hate it. So not only try and identify the model they're operating under, but try and help identify what their idealized operational model might look like. Think about life cycle. MRI equipment today has an average lifespan of probably somewhere around 8 to 10 years. And that device will be pulled out and another device will be put in. If we design the physical facilities to the minimum standards of the first piece of equipment, that means that whatever we did that was smart, hopefully most of it, will be torn out to facilitate the next scanner if it requires a room that's 2 feet wider, 2 feet longer, different shielding requirements. So think about the overall lifespan of the physical facility and build in the equipment and operational flexibility. Seek to understand the client's needs. This means operational needs, this means clinical needs, this means staffing. Architects are great at figuring out what they don't need to know about their client's business. And unfortunately, with respect to MRI, I think we might have carried that too far. And we might be too uninvolved with our clients in this aspect. Try and walk a mile in their shoes. Sometimes that means asking uncomfortable questions. Uncomfortable for you because it shows that you don't understand something maybe as well as you think they think you do. It might be uncomfortable for them because you're challenging the status quo. You're challenging the way we've always done things, which, in my opinion, is a lousy reason to do it again that way. Acknowledge the pace of change. MRI as a clinical service, the economics underpinning it, the technology, the types of patients and types of exams that we're doing is changing with dramatic speed. And replicating a design that you did 5 years ago is probably a significant disservice to a client today. We need to look at the pace of change, and we need to do a little bit of crystal ball gazing to identify what we think that means going forward. These are a few suggestions that I have for the designers, planners, engineers involved in MRI facility planning. These elements, I think, will make you better at your job and will make your clients more happy with the end product because it will be more responsive to their concerns and their needs. And with that, I think we're open for questions. How much time do we have for questions, Colin?
Well, many thanks, Toby, for that informative and interesting session. As ever, we've had a steady stream of questions coming in during the presentation, and we're not, unfortunately, going to have time to address them all now. However, Toby will be answering them all offline, and the answers will be published alongside the on-demand version of this webinar on Metrosense MRI Safety Resource Centre. So if you haven't visited it already, then please do have a look at the link on the resources panel, which is the top right of your screen now. We do have time to answer some of your questions, so let's start with this one. Toby, do you have any references for MEP design standards, HVAC, electrical or fire protection, plumbing?
Yes, I do, and they come from an unusual or atypical source. There really aren't standard design criteria in the building codes for the unique aspects of MRI. However, the VA, Veterans Affairs Department, has HVAC and electrical design manuals, and they include sort of where there are peculiar needs because of this piece of equipment or that piece of equipment, and those include some design guidelines, design standards for MRI rooms. I would recommend those in addition to looking at design recommendations in the equipment siting manuals. So from your GEs, your Philipses, your Siemenses, they will have frequently in the siting manual, not necessarily on the drawings, a set of recommendations. And between those two, I think you can pull up some really useful information.
Many thanks. Next one. Thoughts on scan room door locks? Electronic touchpads versus deadbolts versus proximity badge RFID technology?
Door access becomes really complicated because it will typically involve both building codes and life safety codes, and then that has to integrate with whatever your safety or security plan is. While I would love to be able to give you sort of a one-size-fits-all response to that, unfortunately, I don't think that's really practical. I can give you some basic guidance. I got no problem with the idea of a deadbolt on a magnet room door if and only if it's used to secure the magnet room off hours. A deadbolt on the door in terms of restricting access when we're operational, and God forbid when we have somebody inside the magnet room, this is really problematic. This is a basic principle of life safety in the buildings, that unless you're running a prison, the person inside the room has to be able to get out under their own power, their own ability. If we lock them in the room, it's no longer an MRI room, now it's a jail cell. And so we need to make sure that whatever locking mechanisms we have, that they don't inhibit emergency egress. The person can get out of the room and exit the building as needed. So whatever lock mechanisms you look at for operational, during the daytime security and access control, whatever things you are looking at need to be weighed against the importance, the imperative of making sure that somebody inside the room can't inadvertently get locked in. The other thing that I will suggest is try and avoid the use of combination locks or keypad locks, where all somebody needs to know is a 4-digit, 5-digit code to be able to get in. Information about those codes spreads far and wide. Tie it to a physical key, biometrics, an actual, cut out of metal key, Prox card reader or something like that with unique identifiers. those are sort of my general recommendations in terms of door access controls and some strategies that I think will help you balance the competing interests.
Okay, thanks, Toby. Next one is related to ferromagnetic detection. Question on, we've been told that sometimes it's preferable to put the ferromagnetic detection system inside the room. Is that the best way to do it?
In my opinion, no. I would, in fact, go beyond that, and I would strongly counsel any site that's deploying a ferromagnetic detector to do the exact opposite, to not put it in the room, to put it someplace where it is visible clearly as we are approaching the magnet room door on the outside. Now, there are ferromagnetic detection systems that you can get that are actually a part of the door frame. Those at least are on the outside, but again, not an idealized situation. The thickened wall that I talked about before, one of the advantages that I didn't really touch on is once the ferromagnetic detector, if it has a photo beam that connects detectors on either side of a door opening, once that is 16, 18 inches away from or in front of the door, what that means is that the person who's going through the door essentially is going to break the beam, step into the detector area, and be screened before the door is opened. When the detectors are a part of the door or, just immediately at the door, in the user's mind, if, they're walking up to the door and they open the door and the alarm goes off, they're not clear whether the alarm is for them as an individual or if the alarm is related to the door opening. If we can physically separate those two elements, approaching the door and opening the door, then there's a better likelihood that the alarm condition informs the person that the alarm is about them and not so much about the door itself. So, no, don't put it on the inside of the room, period, end of statement. Do put it on the outside, and to the extent that you can, create that separation distance using the thickened wall technique to put the detector a minimum of 16 inches, hopefully, in front of the position of the door into the MRI scan room. It gets you better functional results. Some of the contemporary ferromagnetic detection systems have logic functions that essentially negate signal from the door opening. In the body of the presentation, I talked about how that can be a conflict for some systems. So if you get the more advanced systems, you don't necessarily need that physical separation to benefit that function, but it still is preferable even with those more advanced systems because, again, it separates the door opening from the individual approach and makes those two distinct elements, and so people better understand the alarm is for the individual and not for the door opening.
Thanks, Toby. Very clear. Right, we are overrunning now, but I'd just like to fit in one final question that we've had a few people ask. Do you recommend Zone 4 doors swing into the room? Isn't that a problem during a quench?
And this is where I give a mea culpa. Probably 10, 15 years ago, I was the loudest voice calling for only outswinging doors in MRI rooms. That was based on old MRI door technology and also different interpretations and enforcements of contemporary building codes. It used to be that RF doors were predominantly friction fit. You had to kind of shoulder check them to open or close them fully, that there wasn't a latch in them. And it used to be that the code officials were more permissive about not requiring latches for MRI room doors. Both of those have changed. Now, we now have air seal type of doors that create an airtight enclosure at the door opening. We also now see latch mechanisms of one form or another for doors in MRI. Almost universally now, the friction fit doors are few and far between. Those changes mean that the outward swinging door, if the magnet quenches and the room pressurizes, a latching door, an airtight sealed door, is not going to be pushed open by the positive pressure building up inside the room, which means that even if the door swings in the outward direction, it's not providing the safety benefit that we thought it was. So the contemporary design standards say put in an overpressure relief mechanism to allow that pressure to escape the room some other way, in which case the door is not helping us or hurting us, so we can swing the door whichever way we want. My personal preference and my general recommendation is, with the use of ferromagnetic detection systems, among other reasons, have that magnet room door swing into the MRI scanner room. That seems to work out better in terms of effective space use and not making the control rooms, which tend to be really small anyway, even smaller because we have to keep clear the area where the door swings. It improves the functionality of the ferromagnetic detector, and as long as we have the overpressure relief provided through another mechanism, the door swing isn't going to help us anyway, so we'll just make sure we take care of that through another means, and we have complete flexibility to do whatever works for us functionally, programmatically. So I hope that answers it, and I apologize for being the one who really sort of set in motion the all doors must swing out kind of standard. It should not apply today with contemporary MRI sighting and planning and the radio frequency door types that we see.
Many thanks, Toby, and thanks, of course, to everyone who's joined us today. Unfortunately, we have run out of time. You will receive an email later on today with a link to join the webinar again on demand if you wish, and so please do forward this to any of your colleagues who may have missed this live session. A final reminder to please complete the survey that will be displayed at the end of the session in a couple of seconds. That'd be really helpful to us. So many thanks again. Goodbye until next time.
Thank you all.